Good afternoon, everyone. Thank you so much for attending today's session. My name is Chris Vantine, Chief Technologist for the Western region at Red Hat. And I've been with Red Hat for about 12 years, working with strategic partners and customers along the West Coast. And certainly one of the hot topics with our customers is how to enable digital transformation for their businesses by accelerating application delivery. And ultimately, the discussion usually leads around DevOps and some of the enabling technologies like Linux containers and container management such as Kubernetes, and also about the security implications. So today I'm going to talk about that and much more. But first off, what is driving the industry? Andy Grove, about 20 years ago, talked about how only the paranoid survive. And this isn't necessarily about security, about inflection points. When there's massive amounts of change in the industry, and each company is tasked with deciding, do I change and adapt and potentially thrive, or stay as is and potentially fall by the wayside? And we're seeing that happening across many different industries, whether it's retail, finance, media, or transportation. Disruption is happening, and the incumbents are being replaced by those who are embracing software as a competitive advantage, and their ability to deliver new products and capabilities quickly to the market is helping them stay ahead of the competition. And what is enterprise IT to do? A typical enterprise takes 6 to 9 months in between deployments, right? And this simply can't happen if they want to stay ahead and relevant in the industry. And what are the underlying challenges that IT is having? Maybe it takes too long to provision the servers, or the developers don't have access to the tools or the environments that they need, or potentially when applications are delivered to production, they fail. And so as I've talked with customers along the West Coast, there's some commonalities, right? From an organizational perspective, what I've seen is organizations are siloed. You have their developers, your testers, and your operations all siloed off. And as a nature, they've evolved into their own set of processes, their own set of tools, making it difficult to collaborate and communicate. And as a result, software quality has been impacted because it's too challenging to move the application from dev test into production. And so how does IT transform from a cost center into an innovation center? Well, look what the leaders are doing, the disruptors, right? They're releasing software frequently. They're able to rapidly innovate and turn around and drive new capabilities to the marketplace based on changing market conditions and customer feedback. And so IT must evolve. There's a shift to move to DevOps, to containers, and microservices on public or private cloud infrastructure. DevOps breaks down those walls and allows developers to quickly deliver the software with higher quality. And microservices allow you to decouple that monolithic application and rapidly innovate with small, loosely coupled services that can rapidly be deployed into production without risking the entire business on a single release. And containers provide the ability to package that application once and deploy anywhere, whether it's dev, test, production, physical, virtual, private, or public cloud. And containers give you that promise of that iPhone-like experience where you can simply install the application in a matter of minutes. Right? Why is it so difficult in the enterprise to deploy applications? And so DevOps is all about breaking down the walls, but it's not just technology. It's culture, process as well. Culture reflects a lot of the principles around an open source community. Transparency, collaboration, and trust. Bringing together cross-functional groups, giving visibility to the code early in the process. And from a process perspective, a switch to continuous integration and continuous delivery. And continuous integration encourages developers to check in early, test their application, identify issues early in the process where it's much less expensive to resolve the issue. And continuous delivery allows you to deliver the application when it's needed by the business in a matter of minutes or days. And the feedback loop allows you to rapidly shift direction on changing market conditions as well. And the underlying technology that these companies are using is increasingly open source. Open source is a key part of this new software factory, providing you software automation and delivering new capabilities to the marketplace, whether it's Linux or containers or infrastructure or the development tools. And does anybody recognize what this is a photo of? Right, this is the Intel fab that's being built out in Arizona. And the reason I show this is because about 20 years ago when I joined Intel out of school, they were going through the Pentium bug. Right? Does anybody remember the Pentium bug? The floating point unit, it cost them almost $500 million write-off. Negative PR. And Andy saw this as a key inflection point for the company. Good companies survive, great companies thrive. And what he did is he invested in continuous integration and validation for his chip factory. Right? So behind this factory is a software factory. Now it's tens of thousands of computers, providing the designer the ability to submit their design and have it automatically tested, getting the issue out of the way early in the process. How about this factory? Does anybody recognize this one? Right, exactly. This is the Tesla automobile factory, and I show this for two reasons. One is automation. Software is enabling efficient production of these vehicles with high quality, but even more importantly, for the first time as a consumer, I can buy a vehicle that actually gets better over time. They're able to deliver software updates over the wire. In 6, 12, 18 months down the road, I know the car's gonna get better. Better battery efficiency, better 0 to 60 time, or improved applications in the center console. Who has heard about a vehicle recall? Right? It seems like every week a manufacturer has a vehicle recall. Well, the ability to deliver updates over the wire is a competitive advantage. Think about autonomous driving coming down the road. What if there's a security update? They're able to deliver it rapidly rather than having a physical recall. And this is going to save them millions of dollars over the competition. And so it's not just these. Many companies are seeing improved deployments, better lead times, lower failure rates, better recovery. But it's not just how many times you can deliver the software. Right? When a IT can deliver a new capability to the marketplace when the business needs it, IT becomes a strategic differentiator rather than a cost center. And what about security? Does anybody recognize these logos? Right? I show these because a couple of years ago, they represented the companies that had 1 billion data records breached due to a security compromise. Right? And when I started at Red Hat, I would talk with the operations team because security started and ended with operations, really didn't concern the rest of the organization. And the common response I would get is, well, those servers are behind the firewall. We don't have to patch them, right? And that type of approach towards security certainly needs to change. And so that's why you see a movement towards DevSecOps. Security needs to encompass the culture, the process, as well as the technology as you make this transformation. And security is a big part of containers and an advantage that containers provide because they free up the developer from the restrictions typically placed by operations in the security teams in terms of compliance and security policy, because it allows the developer to package all their immediate dependencies in the container image and then build it once and deploy anywhere. And the typical process for the container environment is to build, ship, and run. Right? I can repeatedly build my software container and specify exactly what it's in it and reduce the footprint so I'm not as vulnerable to potential security issues. I can share that image as is rather than rebuilding, reconfiguring as it moves from test into production, introducing the possibility for change and compromises. And then I can also have a consistent runtime environment, just like in Java, across all my platforms, physical, virtual, private public cloud, but for any language, not just Java. But containers are much more than that when you're deploying into the enterprise. What about my brownfield applications? What about my greenfield applications? What about global data centers? I need the ability to schedule. I need the ability to manage the life cycle of these images, monitor the health, recover from failures, the ability to discover microservices that my applications need to interact with. How about monitoring and logging? Or scaling up and scaling down, how to become more efficient. And the persistence for my brownfield applications. I need persistent volumes or persistent data stores. And these microservices are a logical application consisting of many microservices. I need to be able to scale up, scale down, or roll out updates to these individual components. And certainly, security. How do I automate security at scale in a multi-tenant environment where different business units have different requirements around security? And so this talk, I'm going to focus a little bit more in depth around the security components. Kubernetes is a container application platform released by Google to the open source world based on their experience with containers over a decade. And so they've open sourced this, and Red Hat is a key contributor, and we deliver our Kubernetes version called OpenShift as well. And so this platform enables organizations to build out an automated software factory, taking manual processes or things that developers are currently scripting and have it automated in an opinionated way, as well as providing modularity and flexibility so you can integrate it with your existing processes. And it also brings to the table automated security, right? Encompass not only the culture, the process, but also the technology. And so when it comes to security, there are many different areas that Kubernetes brings to the table in terms of automation around security and some best practices for Linux containers. And we'll talk about them around images, how to build secure containers, where to store images securely, how to integrate security into your CI/CD process, as well as a hardened container host. So first off, some tips around container images. Treat them as immutable. Separate your code from your configuration and your data. The code goes into the container image. The configuration, you would store an environment variable or secrets if it needs to be encrypted, and then separate the data and put it on a persistent volume or a traditional data service that can either be on the platform or external. And what inside the container matters as well. Red Hat did a scan at one point in time of the public container images and found that 64% of them had a medium or high security issue. Right? If you don't know, right now probably your developers are downloading something from these repositories and bringing them into your enterprise. And so you need to have a process to address this. Not only when you pull it down, or where you're pulling it down from do you need to be aware of, but also on an ongoing basis. Because over time, whether it's a C, Java, Node.js, PHP, Perl application, they're all pulling in different components of the operating system into the image. Now, what you may not see in the second column in the JRE is a little triangle, and there's a number 66. That represents 66 security notifications have been issued, and that at the point of this slide, and since RHEL 7 was released. And so on an ongoing basis, you need to have a process from an operational perspective to monitor and scan these images for security issues. Also, in terms of image signing, right? Sign your images so you know they're from a trusted source. Right? Kubernetes integrates with this. RHEL 7.2 added image signing support as well. And what about builds? What are some best practices around building your images from a security perspective? Right? When you're building an image, you create a build file, treat this build as a blueprint for how to recreate that image, right? Don't log in to the container, make changes, and then exit out, because you'll have no recipe for how to rebuild that. And when that person leaves the organization, it'll become very difficult to reproduce. Also, a good practice to version control your build file. Think in the mindset of a software developer. And be explicit with the versions as you list them in the build file as well. Don't use latest, right? You don't know what version that is. How do you reproduce that image if it's latest? Right? And be aware that every time you use the run command in the build file, it creates another layer and creating additional overhead. Right? In terms of storing these container images, we talked about the public registry. Well, enterprise, you need to think about using a private registry, right? Having role-based access control, having policy on who can upload these images, who uploaded it, where was it built from, what's the history of this image, etc. And so that provides great security around what's being distributed in your enterprise. And CI/CD with container security, the typical CI/CD process in a container factory typically looks like this. You have the software developer checking in your source code and triggering an automated build, maybe in Jenkins, and it's pulling down a base image. That's a container image. Maybe it's Rel 7, and maybe it's layering on top your application server like JBoss, and then merging it with the code. And you may use a build image to actually produce the artifact so it's repeatable, and then put that artifact into an image registry, and then it's distributed as is into dev, test, and production. There's no rebuilding along this process, right? And so what does that mean? It means from a security perspective, I always go back to step one when there's an update or an issue. And so how does this look in terms of roles and responsibilities? Right? Today, you typically have a core build owner that maybe is using a Kickstart file. The middleware team is producing the JBoss application server, and they're typically maybe a tarball. And then the application developer is contributing the jar file. Well, that doesn't work very well in the DevOps way. They're all speaking different languages. They're using different tools. And so the build file normalizes that across all these teams. And now they can use the build file for the container to speak and talk the same language, be more efficient, yet still own each individual layer. And so you can build your application layered with a core base image, and then the application server, and then the application code. And then each team is responsible from a security perspective for the respective layer. And then there's automation in Kubernetes and OpenShift to actually provide things like image streams. So if there's an update to any one of those images, it could trigger a rebuild for you and deploy the updated, more secure version. Also, from a security perspective, what about your CI/CD pipeline? Your developers are probably using something like Jenkins in a DevOps world to automate continuous integration testing. Right? What about security? Where does that fit? Right? You need to have a standard process and a regular process to scan your images. So integrate that into your pipeline. Right? Whenever you build an image, scan that image for security vulnerabilities, and does it conform to your security policy? And so what would you use to do that? There are many tools out there. OpenSCAP is an upstream tool that you can use. It provides the ability to scan physical, virtual container images online, offline for known vulnerabilities, RPM issues, or issues with security policy. So you can define the security policy. And each distribution provides a security guide and the checklist as well as a known vulnerability list. And OpenSCAP provides tooling to help automate the scanning of that. It's a daemon or a command line tool to run those tests so you can integrate it into your pipeline. And then it provides reporting so you can view the issues from an audit trail perspective, as well as provide remediation of any issues by providing an automated script to correct the issue with the security policy. Maybe you have a legacy daemon such as TFTP enabled, and you want to make sure you disable that on your images. All right, so we talked about CI/CD in terms of a security perspective. Let's talk a little bit more about continuous delivery from a container security perspective. This is typically rolling out into production, right? In a current environment, your security process may be to patch each individual server. But did those patches go through testing first? Right? In a CI/CD pipeline, you want to go back to step one rather than directly patching your production environment. And so what does this look like is that the developer will build version 2, which addresses the security issue, put it into the container registry, maybe your private registry, and then each environment will pull that down through your pipeline. So it'll go to QA, staging, and then finally into production. And therefore, everything will go through that security scan that you implemented as a part of your pipeline. Right, so there are many strategies for that final step of deploying and updating your production environment. Typically today, companies are automating this by writing manual scripts. Well, it doesn't make a lot of sense. It's typically the developers doing that to have their time wasted on something that really isn't business differentiating. And so Kubernetes provides automated deployment strategies to quickly roll out updates. And that's a key requirement, is how do you quickly roll out updates that address these security issues in a matter of minutes? And so strategies such as blue-green deployment, rolling updates, canary deployments, and even testing it out with A/B testing is all automated in the Kubernetes platform. So let's take a look at how you would use these. First off, the blue-green deployment. Version 1 is your blue, and you have all your traffic currently being routed to that through the load balancer in Kubernetes. Maybe it's your F5. And then the development team wants to roll out a security patch and call it version 1.2. So instead of replacing the current environment, Kubernetes allows you to virtually create a new cluster. Right? So I can totally switch over to this entirely new virtual environment that's a mirror of the existing environment with just the application code updated. And so as it runs through testing and CI in parallel, once it's completed successfully with that security scan, I then flip the route over to that new virtual environment, and then it starts receiving the traffic. If there's an issue, I can revert the route back to the previous environment automatically. And boom, I'm right back up and running. Also, support for rolling updates with zero downtime. Right? So now you have version 1 out in production, and I want to move over to 1.2. So that's going on in test and QA. Once that's completed, I deploy the environment, and there's a health check. This is a readiness probe to see if 1.2 is ready. And so when that comes online based on the logic I defined, it will then route the traffic to that updated version, and I can gradually increase the number of nodes with the new version as I gain confidence. And so gradually, I roll out 50%, and then eventually, I'm at 100%. And so Kubernetes is taking care of updating the load balancer and bringing in these new nodes. I don't have to file a network engineering ticket and wait for that update to happen. I also don't have to worry about IPing. I don't have to worry about mounting storage, etc. It's all taken care of for me if my application depends on it. I also can enable my developers to do things like A/B testing. Maybe that new security patch, I'm a little concerned if it will have a negative effect on the outcome of my website. And so here you have a mobile phone with a web app, version A and version B. Version B has the new update. And so I can use what's called canary deployments, right? I can try out a version and see, but not fully commit to it. And so currently, I have version 1 receiving 100% of the traffic with a 25% conversion rate. So my customers are clicking on that a quarter of the time. And so this version B that has the new security update, I want to make sure it doesn't negatively impact. And so I can update the route and tell it to adjust traffic by 50% to that new version. And maybe I have some application logic dictating the routing as well. Maybe it's only folks that are in APAC region or Europe that should go test out that new version because maybe it's a lower risk for my business. And so here I see there's a 30% conversion rate. So, wow, it's actually not only improved, but also more secure. And so I'm going to go ahead and roll 100% of my traffic over to that new version. And likewise, I could do a rollback if I found out that the conversion rate actually declined with that new update. Perhaps a new feature snuck in there into my code. Right? So that talks about deployment models. What about host security? What are some best practices in a container environment? You know, Kubernetes provides some automation around this and setting and configuring from a security perspective. But also, you know, you want to make sure that you're not running your container images or instances as root, right? Because if they break into the container it's running as root, then the host is vulnerable, and then the other containers are vulnerable as well. You also want to limit SSH access. Right? Get out of the habit of logging remotely into a container image or host and try to access it via API services. And also use namespaces. Namespaces provide a logical separation in terms of UIDs, GIDs, et cetera, so that they don't conflict with the host or other containers. Define resource quotas, and Kubernetes can set these for you so that you don't have the noisy neighbor problem of consuming other resources. And then also enable logging. There's central logging built in. And be sure to apply security errata, not just in an automated scan of your images, but also the host systems on which your container images are running on. And Kubernetes will allow you to apply automatically to security contexts or set comp so you limit the capabilities that the container image can have. So we talked about images through container hosts. There's also a large group of other capabilities around networking through federated clusters that we'll quickly go into as well. First off, you know, Kubernetes allows you to set up virtualized, compartmentalized environments that are complete mirrors of each other. So this enables the developer to have a production-like environment on their laptop. Right? In a DevOps culture, it's very important to have early access to production environments so you get those issues out of the way. And so I can virtually spin up these environments, spin up multiple test environments, all with isolated networking. Also in production, I can isolate the networks on the containers, even though they're sharing the same physical host. Also, storage security. Kubernetes provides the ability to set the security context constraints around this storage, so only processes with the right security authorization can access the persistent volume. But also, I can define storage quotas so they don't overconsume the storage as well. There's also an API layer, which integrates to your enterprise authentication, where you can define who can do what, whether it's a service or an end user, whether it's a developer or operations. And then also centralized logging. You can bring together all the standard out logging, search it, view it, and react upon it as well. And then from a monitoring perspective, I want to have a holistic view of all my data center that's running with a containerized environment. And so out of the box, the monitoring and the logging can run as a container instance on my Kubernetes environment and providing me the ability to monitor the health and then automatically recover a failed instance with a replacement container instance, as well as trigger events or actions. And then also we're bringing federation into Kubernetes. And this allows all different use cases. Maybe you have an application that has different security requirements. Right? In dev and test, maybe you don't have the same level of security, and so you could actually place those workloads maybe in your less secure public cloud instances, and then maybe the application in production, because of data reasons, you want to bring it in-house and run in a more secure type of environment. And so you can get a holistic view across all these providers with Kubernetes and have the freedom of choice to deploy the applications where it makes most sense for the business. All right, thank you very much for attending this session. All right. Feel free to reach out on email. I'm also on LinkedIn under Chris Vantine, or Chris Vantine on Twitter as well. And look forward to hearing from you, and have a good day. Thank you.